Thank you very much, Simon. It's a pleasure to be here. Sustainability is really something that is really dear to my heart. I've been spending 15 years actually more than 15 years in construction, working on structural design and construction on a number of projects. And actually, from my current role as Structures Technical Director, over the summer I will also embark in a new role as Head of Sustainability for Langor in Europe. So that tells quite a story in terms of how decarbonization is important and how, in particular, like from structures and technical design, you can really make a differentiating factor. I will take you on a journey today of what Langor discovery and strategy has been, particularly in the last 18 to 24 months, as we have embarked in a quite ambitious and important sustainability strategy that has sustainability approaching a system thinking approach, but with a strong focus on decarbonization and how, as contractor, we can really have a collaborative dialogue with all the different parties and stakeholders on a project to really drive carbon down. So before we start, please allow me to get a bit of context because that will be really important to understand Langor journey and how it's important that as an industry we recognize all the different interlocking mechanisms. So Langor launched officially sustainability strategy last year, and then it can be summarized really in three numbers: 30, 50, 50, meaning that we're aiming to be net operational zero by 2030. That is around scope 1 and 2 emission, 50-50 gender parity by 2033, and very importantly, full net zero by 2050. And that includes not just scope 1 and 2, but the whole scope 3, meaning achieving net zero across the whole project portfolio, including emission from supply chain. How is this panning out in terms of the operating model of a contracting company like Langor, with many operations, many different type of projects across the building and infrastructure business? First of all, I have to outline the interlocking mechanism between the human social aspect and the environmental aspect. You will hear me talking a lot about people and the power of collaborative efforts across project teams, designers, contractor, and supply chain. And that is also reflected in one of the targets about diversity. In regards into carbon in particular, I think it's important that our strategy is underpinned by definitely like four important aspects. First of all, collaborative dialogue with supply chain. Secondly, optimizing design. And that will be quite importantly one of the focus of my talk today, because as contractor, we can really drive our expertise in having that collaborative dialogue. And there are savings and implementation that can really be realized earlier on with that optimization focus in mind. Quite importantly, modern methods of construction is fundamental, because that could really drive further innovation in having safer construction site with fewer people, and also definitely reducing waste. And last but not least, innovation goes around trials and R&D, different products, different technology that can really be measured if we have that collaborative behavior that I talked about earlier, but also ways to track the improvement. And that's where carbon calculator really comes into play. I believe that if I can get some tech help to get on the next slides, please. Fantastic. Thank you very much. One important thing, and that is at the heart of the current innovation and improvement in construction, is around the strong link between digital engineering and engineering. Digital tools and data approach can really help this, and really get stakeholders like us in contracting really at the forefront and having that collaborative dialogue and track also solutions in real time. The power of the digital model and then all the information that is contained with it, it's something that can drive excellence in engineering. Also, it's really important in terms of Langor, but also for the wider industry, if we push elements like design for manufacturing, disassembly, and modern methods of construction. So you will see how the carbon tool that we have developed is strongly linked to this approach and the joinery between digital and technical excellence and engineering. In terms of approach, I think it's very important also to discuss a typical framework that our project teams try to adopt in discussion with clients, supply chain, and consultant partners. Of course, like material reduction is one of the key elements that can help reduce embodied carbon. uh, Build lights, a linear design, and all of this can really be tracked with the use of carbon tools, and then assess all the different solutions as the project developers throughout the life cycle. And again, I will not emphasize enough how it's important in building collaboratively. Design is not just a box where, as contractor, you cannot collaborate. It's important that this is perceived as a real collaborative effort, and also that it can really unlock future opportunity for the next generation of product and testing new technologies. So in practical terms, Langor has really tackled embodied carbon as a key performance indicator, and then we adopted the measure, reduce, minimize, and eliminate approach. Of course, we cannot be net zero tomorrow or next year. Is a long journey ahead of us, but it's important that the bases are actually put down to making sure that we can actually track the improvement and highlight the key areas of development. So our project engineers and our team, as we approach a project, really we are adopting a hierarchy of carbon reduction, using to working with potential client and partners and adopting this technical design framework. First of all, it's very importantly, we have mandated embodied carbon assessment of all projects starting from tenders. In the last 18 months, this has been mandated in particular in work winning activity and pre-construction, focusing initially on the upfront embodied carbon of structure and substructure component. This has been expanded into considering more projects throughout their life cycle, including project on site, so in the live project phase, and also we were expanding the remit not to consider just structure and substructure. And quite importantly, I'll touch upon it as I talk about the tool in particular that has been framed within the particular remit of industry standard. So in terms of the upfront embodied carbon, I'm referring in particular like on the carbon emission associated with the construction of the building, so up to the point of practical completion. Quite importantly, also governance processes, it's something that we are implemented as a way to track, measure, and compare project across different typologies and different sectors. And all the figures are tracked in a central database and are important as we build our journey towards net zero. And also, it helps the development of lower carbon products. How again we can work with the supply chain and consultant partners and clients really to deploy the next generation of project and technology. So, what does it mean? in real practical terms. I'm sure you're all familiar with carbon calculator and tools that are widely available on the market. So internally, we are using this tool as well, but the importance of what we developed in terms of the LOR carbon calculator is the real time and effectiveness of decision making and optioneering in real time, using the power of digital tool for collaborative decision. That is something that I really want to emphasize again and again, because it's something that as a contractor and definitely like as actor in the industry, it will be it's really important. So the LOR carbon tool is a software agnostic tool that takes models from variety of sources. It could be a Revit model, it could be a Navisworks model, it could be any source of 3D model with information. He assigns a unique ID classification, and then carbon intensity rates are mapped to the different components, either via industry database. In this case, we have been using quite extensively the ICE database, or EPDs if available from our supply chain network. That generates a heat map. You can see an example on the third rectangle boxes. And with that, you can generate different range and optioneering based on variety of changes and discussion within the project team itself, or consultants or client. In particular, like linear design, better specification, and accurate assessment that have been quite important in this journey. One thing I would like to stress also, and then we'll touch in the case studies that we'll present later, it's not just about linear specification, it's not just about your cement replacement and how much GGBS content and percentage you can put into your concrete mix, but it's really about that holistic view. How, in particular, like it's due through deployment of DFMA and modern methods of construction first. Secondly, improve constructability, or in some cases, even like a discussion about volume of components. For example, size of substructure component, size of piles, we can really drive embodied carbon. I think that that's really important. And whilst there is a specific effort in having that discussion as early as possible in the design phase, really until you are on site, it's important to have this conversation. And even when you are on site, it's important to keep track and having continuous milestone to see where are your hot spots areas. In particular, in terms of the heat maps here, like there's nothing that a piece of bread cannot tell. It can really drive attention and help the discussion moving forward. And again, this focuses again on this critical thinking that can be really enabled. So that real-time decision making coupled with the critical thinking of all the team, particularly the project engineers and the technical leaders, can think about different options, so volume reduction, better specification, and also enabling system beginning circular economy principle if there is any possibility of reusing component. And this is like a snapshot of the tool. So it's actually hosted in Navisworks, and it's actually very simple in its functioning because it links quantities to carbon rates that, as I said, it can be taken from either like industry database or EPDs, so that there is the flexibility of doing that. Everything is mapped, and then heat maps can be generated on the screen. And that really allows that fast optioneering, even in the course of a design team meeting with other parties, like different options can really be addressed. And the same thing can be talked in terms of supply chain engagement. So what does it mean in terms of case studies? So I've been talking about the context, I've been talking about the underlying philosophy of really enable the critical thinking and how we can think differently. How has Langor been using this particular tool and this approach, most importantly, in the last 12 to 18 months? So I have a few case studies, and they're both like in the work winning, pre-construction, or also in the live project phase. I think it's important that different phases of project might have different requirement of different focus, but like the important of driving discussion and having a fundamental KPI doesn't change. So the first project is a residential project in London. Is When we initially received the documentation that has been mapped using the carbon calculator, that has been at the very top figure. And that was based on a series of element sizes, full in situ construction for it's a concrete frame, and then with a 25% GGBS. The team did a lot of optioneering with all the different stakeholders, and at the end, like a 19% reduction was achieved. In this case, it was a combination of different specifications, particularly pushing the GGBS. But as I said earlier, it's not just about GGBS, but it's about having that critical thinking approach on how particular different construction sequence, different methodology can help reduce volume of material. At the end of the day, reducing volume can be quite an important strategy. Of course, has to be considered in a whole life approach, but then I think asking the right question and be bold is quite important. Moving on, this a more complex, I would say, office project in London. On this, the reduction was not as substantial, it was not 19%, it was just below 10. But also, this has gone through 5 different optioneering and different solution and quite important discussion. But then the similar principle really applies. And then what you can see also that as part of the tool, we also built a separate Power BI dashboard, so where all the projects are tracked and then all the different performance and elements are actually tracked. This is another office project in London where particularly like the inclusion of modern methods of construction and the FMA components drove the embodied carbon down just a little less, again, the 10%. This was important because different options were addressed, particularly in light of different KPI, cost and program, and a compromise at the end was achieved in discussion with the project team, with the clients, with the external design partners. And different solutions have been driving in terms of particularly of the substructure and the core wall system. You can have this discussion quite easily, as I say, as if you see areas of red. There's nothing like a piece of red on a screen cannot drive in terms of a positive discussion. This is like another more recent example where discussing on a work winning opportunity with a client, we have been asked to come up with different alternatives in terms of constructability of a transfer structure. We were lucky that it was very early in the design process, and then having that constructability input was really helpful in terms for this particular area of the project, driving down the embodied carbon by about 27%. So as I say, it's not just about the specification. This conversation about reducing using embodied carbon for contractors shouldn't be about really how much GBS you can put it, also because GBS is a finite resource, but it's really about, can you reduce the volume? Can you build it differently? Can you deploy system that make it safer and more sustainable? And then at the end, can you have leaner, can you have greener material specification? So all these are good discussion, and it can happen as and when a contractor and designer and client and supply chain get involved. Last, this is a different example. So this is a case study of a stadium we're currently building in the UK. The slide has no name, but I'm pretty sure that you can all guess what stadium it is. So at this stage it's different because we started doing embodied carbon calculation only once the project was actually started on site. So in this case, whilst a lot of the design decisions have been made, I think it's important to still have this model to drive decision making in terms of supply chain engagement, in terms of monitoring in particular, and track how a different milestone during the construction process is value can change. Also, it's quite important that in terms in particular construction data, and I'm talking in particular like that A5 phase in the embodied carbon life cycle in terms of the RICS framework, how like having more projects that actually track the data on a live phase can really help get exchange of data in the industry. So we, as a company, will be start measuring project more and more in that life phase, regardless of what happened earlier in the design, and that applies across the board in the buildings and infrastructure, particularly like to have that monitoring mechanism, but also that data collection that will help us all in the industry moving forward. The last case study I would like to show is around some product developments that being particularly be informative in terms of embodied carbon. As you might know, Langorork has a direct delivery, but also integrated supply chain. So the company owns a factory in the north making precast component, and as such, we are in the privileged position of being able to test the different prototypes. So you can see here our D-frame system. Based on a series of inverted T-beams supporting a rib slab in U shapes. This has been tested and prototyped, as you can see on the picture, and then we are recently assessing different opportunities in terms of how can different products, even like something outside the box, like a rib system in an office space, could really do. So really quickly, as I'm conscious of time, so the system has been addressed against a standard baseline PT scheme. For a total of 275 millimeter depth, and then you can see like the total embodied carbon of that particular floor plate was just short of 200 kilograms of CO2 per square meter. And then using a rib system, even pushing the boundaries of a low carbon concrete, using this, we could reduce quite a substantial amount. I think like the message here is again that that collaborative dialogue, using embodied carbon as a KPI, and in a real-time approach that can really drive that optioneering and have collaborative solutions. And I'm concluding now, and I just would like to share quite an important message. You've been hearing about the carbon calculator, how we've been addressing it, but I can tell you what the tool has done to our operating model. As enabled critical thinking, most of all, has enabled the discussion about having sustainability and carbon as a key performance indicator in the project. And it also started a discussion about the power of digital tools to harness data towards responsible decision making. It has enabled conversation and solutions development with client and designers so that really we can draw on joint expertise and discussion on volume reduction, constructability, material specification, and then even importantly, drive future discussion, actually present and future discussion on circular economy, particularly as we embark as a company more in reuse and refurbishment opportunity, and as well as drive enhancement and quite important conversation with our supply chain. And the more we do that across the board in different level of stakeholders, the more data we can harness to establish benchmarks and and really move towards as a journey to net zero together as an industry.
Q&A. We've got a couple have come through, which I'll run through briefly. Just to let you know, if you do want to put any questions in the chat, then they will be passed over by the organisers to Rosella for a response. So first, we've got a question from Neil Wallace, and actually, to be fair, and one from Jonathan McCarthy. They're both surprisingly focused on cost. And one of them is just that general relationship between cost and carbon. Does cutting carbon cost more? But more particularly, Jonathan is interested in terms of whether there is a bit of a difference between steel and carbon from both a cost and a carbon perspective. So do you have any views on that in the time that we've got available?
Yes, so I'll ask the first question. So there is no direct answer, yes or no, does cutting carbon cost more? The answer is always a very politically correct, it depends. What I will say is that there are certain solutions that will have an impact most likely on your program and on all your cost. What we have been seeing is that it's important to introduce the KPI and give the clients a choice, because some clients will really put carbon at the top of their agenda and even agree to pay a premium to have a lower carbon solutions. Other might not be on that same space. It's important to evaluate all the different opportunities, and that's why optioneering comes into place, because you might have the super low carbon solution that at this stage with the current level of technologies that we have will still cost more, but you can hit a compromise where you have a solution that please everybody. And then but also it's important that we don't stop there, that we continue the discussion, because in 1-2 years time the super low carbon solution will not necessarily cost more. Also, I would like to add that a lot of discussion in the industry about establishing targets, benchmarking, and regulations for embodied carbon targets, and as an industry we have to be prepared. So you might be familiar with discussion of PAZ that was mentioned in Parliament in January, and also the recent cross-professional institution effort in a UK net zero building standard.
Right. Well, I'm afraid I'm going to have to bring the session to a close. Jonathan, hopefully you will get a response to your specific question about steel and concrete via email. But Rosella, thank you very much. That was a tremendous presentation. I think you really have demonstrated the way I think in which Laing O'Rourke are using information in real time to support credible decisions. And I think that's the strongest message that's come out of your presentation today. It's people seeing the facts in front of them that enable them to choose the option that's right for them. Now, I'm going to have to disappear off into the ether for a moment to get into my virtual discussion booth for the next session. So I'm going to disappear for a moment. Rosella, thank you very much. And we'll come back and introduce our next session. So thank you. Goodbye.